So today we're going over questions on 341. We're going to talk about some examples on worksheet 8 and worksheet 10. You don't have school Monday. On Tuesday, we're going to go over worksheet 11, which is getting ready for the quiz. And we will have time for some more questions on anything you've run into, because Wednesday there is both a quiz and a homework check due. Okay? Then we will have finished presenting the new trig stuff. And so we will start working on conics, which is parabolas, ellipses, hyperbolas, circles. Okay? And we will, still the next couple quizzes, we'll have a few trig questions, just like kind of we've spiraled the information in the last couple units together. But within the next couple weeks or the next couple quizzes, the trig stuff will be done and gone for a while, okay? Not completely. It will come back when we do vectors and polar graphing. We will have to use some trig stuff later. But conics are next in our book, and I'm actually going to go in that order because when I'm gone to Florida, you guys can do some conics practice. I know. I'm going to be gone for 4 days. I know it's a tragedy.
Say hi to Mrs. Weimer's
What?
Her ex-husband lives in...
No, he doesn't.
Apparently all my teachers decided to.
Okay, we're recording. Let's just get back to the lesson.
The truth is, he lost his eye.
He does not live in Florida.
Yes,
he lives in
lost his eye
Rockford.
to an alligator.
He lives in Rockford.
Yes.
Probably just told him that surprise.
Her mom lives in Florida. Her ex-boyfriends might live in Florida. Okay, maybe we should record this over again.
We should probably restart the recording.
All right, what's the lesson? Do we have questions on the bookwork?
The lesson is don't go to Florida for this one alligator.
Anybody have questions on the bookwork?
Or you might get the sun nerves to throw it.
Okay. I'm going to close this if no one has questions yet on 341. All right, gone. Worksheet 8. This I'm going to do some examples on. When I first pulled this worksheet out and looked at it, I was like, oh, this is going to be tricky for them. But we've done so much of this equation solving now that when I looked at it today, I was like, oh, this is easy. That's what the student said too. Let's see how you guys feel. It says find all the answers between 0 and 2 pi for 2 cosine some Greek letter equals 1. I'm just going to go with an x. How's that sound? How do you solve that and find the solutions between 0 and 2 pi?
Cosine of 1/2.
Okay. Can you picture that yet without touching your unit circle sheet?
Nope.
Cosine is over only half a unit, which means it would go up further to hit the unit circle. It is pi over 3. Now, where else is the cosine positive besides quadrant 1?
Quadrant 4.
4. So then we'd be at
Negative
5 pi over 3, because negative pi over 3 doesn't fall between 0 and 2 pi. You're using your inverse unit circle, the unit circle you're not supposed to be looking at right now. Okay. It's fine if you use your unit circle, but when you get to calc, you're going to have to know these fast. So, all right. We move this over. It will say the cotangent of theta equals what? 1 over square root of 3. We could simplify that, but I'm going to leave it because cotangent is just x over y, right? So we're looking for something that has a 1 in the x coordinate and a square root of 3 in the y coordinate. It actually is the same as this, isn't it? Pi over 3. Now, I don't think it's in quadrant 4, though. Why would it also work in quadrant 3? Because 2 negatives would make a positive. So that's 4 pi over 3. Does that seem okay? Everybody all right? All right. Some of these look really messy. Like just this number 4, I'm not going to finish it, but it looks kind of scary. But what happens? If we subtract 6 cosines, we get what? Negative 4 cosine of x equals negative square root of 12. Cosine of x equals, well, first of all, 2 negatives would make a positive, right? And square root of 12 is 2 square roots of 3. So we end up with, which is something you can find on the unit circle, okay? So even though it looked really nasty to begin with, it was just some algebra. All right, you still need to finish that question. It's not the answer. Okay, the second section on the page says find all solutions, which tells me right away I'm going to need some plus or minus 2 pi n or pi n or whatever. And it says nearest thousandth, which tells me I can probably solve by graphing on the calculator. It also means I'm probably not going to get things that are on my unit circle. So on this first one, if I get the sine of x by itself, I'll have what? 3/4. Okay. No 3/4 on my unit circle. I could draw it, find the cosine and the tangent, but that's not going to tell me what the angle is. I could even do second sine of 3/4 and get a decimal, right? And that is going to be one of the answers. But how often does this need to repeat? Every 2 pi. How many times does the sign hit positive 3/4 in the first 2 pi? Picture the graph, or graph it on your calculator. Yeah. The sign does this, right, by 2 pi? So it hits that value twice. We need to find both of them. In the good old days, we would do second sine of 3/4 in the home screen and find this decimal. And then we would do pi minus that to find this decimal. You guys can just graph it. If you put in y1 sine x and y2 3/4 or 0.75 and do a zoom trig, then find these two intersection points right over here, you'll be good to go. Now, I don't remember what I was going to say. Just totally blanked out. What mode do we need to be in? I think that's what I was going to mention. Radians, yeah. It says directions, say radians. All right, so somebody give me the decimal, one of them or two of them. 848. Okay, the first intersection point, or what you get when you do second sine 3/4 on the home screen, is 0.848, and that will repeat every 2 pi. The second solution over here is pi minus that number, or you can just find that second intersection point. 2 point something, I think, if I remember right. Okay, we're just doing intersects. Making sure we scroll over near this second one for our guess. 2.294 is absolutely right. Plus or minus 2 pi n. Anybody have a question? All right. The second example here, if we subtract 3 cosine over to this side, we have cosine of x. We add 1 over to this side. We have equals 5. Okay. If we graph that, how many points of intersection are we going to find? Very good. This has no solution because the cosine graph only goes from 1 to -1, right? You guys have a grand total of like 3 questions on this, right? This little section to do left. At least one of them's a no solution. Okay, maybe 2. All right. Make sure you know how to do this, though, because there could be one on the next quiz where I ask you for decimal solutions. It's just graphing. All right. What about when we get down to this section? Do we want to FOIL this together? No, it's all factored for us. We just want to say the sine is 1 or the sine is 1/2. Can anybody do that without your unit circle? Where's the y value? 1. Pi over 2. Okay. Sine is where the y value is 1/2, so you only went up a little bit, so you only went pi over 6. Where is the sign positive? Also in quadrant 2, so 5 pi over 6. And we're back to 0 to 2 pi, so we don't need any plus or minus business. That was really nice on this worksheet. All right, what are we doing on the other example here? We're factoring out something or just...
No, never mind.
There's 3 terms, okay? So you want to pretend it says 2u squared minus u minus 1 equals 0. Go back in your algebra brain. 2u and u, 1 and 1. If you like doing slide and divide, you could do slide and divide till you figure out the factors, okay? I think the minus goes there and the plus goes there. So it's going to be 2 sine of x plus 1 and sine of x minus 1. There's a plus and a minus 2, which gives me the negative 1 in the middle. All right, is it the same answers as the last question? Close. One of them is, but not all of them, right? Because it says the sign is negative 1/2. So we still have a pi over 2, but the sign is negative in what 2 quadrants? Yeah. So quadrant 3 for pi over 6 is 7 pi over 6 and 11 pi over 6. Somebody checking me? Now, some of them look really nasty when they're going to factor, and therefore you will get some no solution. Does somebody want to pick one? 8, 9, 10, 11, 12, 13, 14, anything? Just pick one. 8? That one you're just going to take out a sign. Okay? But what about one of these ones that has weird numbers like 7s and 11s? If we look at 14, this says 2 cosine squared plus 11 cosine, I don't know why it's got a G, plus 5 equals 0. So it's like 2u squared plus 11u plus 5. How would that factor? 2u and u. We need to get a 5, so 5 and 1, right? It's got to go like that so that we get 10 plus 1 is 11 in the middle. So what is this going to look like when I think about going back over here? So if each one is equal to 0, we have the cosine is negative 1/2. And the cosine is negative 5, which is not possible. So we're down to finding a couple solutions here. You need to find those 2 solutions and you'll be done. Make sure you write on your paper G equals blank, comma blank, and then leave it blank, because that's what they do in directed study all the time. When I write that down, equals blank, they think that's what they should write on their paper, equals blank. They turn it in. All right. On the back of worksheet 8, we have some review of inverse functions. If you need me to do any of those, I can. Some of those you can use your unit circle for. Some of them you can use, you'll have to draw because they're not on the unit circle. Then we have an identity or 2. We have an angular and linear velocity question and a couple multiple choice graphing questions. Anything you want me to do on that side? Destroy problem? Okay.
Yes.
It says a gasoline-driven lawnmower has a blade that extends out 1 foot from the center. What is that telling us? The radius is 1 foot. The tip of the blade is traveling at the speed of sound, which is 1,100 feet per second. Through how many revolutions per minute is the blade turning? So what is this? It is a linear velocity when it's feet per second. Okay, what's the relationship between those? What? Yes, very good. Faisal said V equals R times W. I wrote W times R, sorry. So we don't multiply those two together. We're going to have to do what? Divide. Okay, so we have 1,100 feet per second equals 1 foot times some angular velocity. Now, what's our label going to be? The feet are going to divide away, so we're going to have nothing per second, which is where angular velocity comes in with radians, right? So when we divide, we get radians per second, because an angular velocity is always radians per time. Okay, you're done, except it doesn't have the right units. What do they want? So we have 1,100 radians per second. What do we need to do? 2 pi radians is 1 revolution. 60 seconds is a minute. Okay. I can stop right now and still half of you will get that problem wrong. What's everybody going to do wrong? Yeah, not finish it is a possibility, but... Okay, or they're going to forget that those are both in the denominator. If you type on your calculator 1,100 times 60 divided by 2 times pi, yes, you have to use parentheses if you want to do it all at once there, or divide by both the 2 and the pi. It's fine, just write it down. Everybody can do it.
Can we do that improving that? Yeah, you type it in the first one.
The first one? This one? You know what? I did this a really complicated way, and somebody last period said, well, can't we just do this? And it's like 2 steps. Do you want to work with the left side or the right side?
Left and right.
It goes really quick if you work with the right. Now, my thinking was I needed to multiply top and bottom. I was going to multiply by 1 minus or 1 plus sign. I don't know, but that was a really bad plan. What could we multiply by that would get us close to this cosine squared business? If we do 1 minus sine of t, whatever we do to the bottom, we got to do to the top because we're going to be a form of 1. Okay. How do we want to write the top? 1 minus sine times 1 minus sine. Do I want to FOIL all that together? No, because it says right here, 1 minus sine quantity squared. And the bottom, we should show, since it's a proof, we should show what we get. And what we get when we FOIL that together is 1 minus sine squared. And 1 minus sine squared can be traded for a... I could have made that problem so complicated. I was like, okay, we're going to do this, this. And they're like, well, can we just... Yeah, we could. Worksheet 10.
They should come in more often, check the homework tracks.
Yeah.
Okay.
And I don't remember how I did it on the sheet. I might have done it the shorter way, but when I looked at it today, I was all ready to start working with the left side and make a big old mess out of it. And all right. Worksheet 10. What's different about this one? The top. We're back to all solutions, so we're going to need some plus or minus stuff again. Now, what are we going to do on 1? Take out a cosine. What are we going to do on 2? Nah, somebody's going to get confused. This is just another way of writing sine squared of x. So, factor it. It's going to factor, not take out anything. Okay, I'm just going to stop there. Let me give you minutes, you can do it. Don't forget you got to put plus or minuses on this one, right? Anybody know if Jenner wrestled yet today? Did he? He's on it. Oh, he doesn't wrestle. Okay. They go today, and then if they qualify, they go again tomorrow, or how does that work? Today and tomorrow for sure? No, you better not. All right, are we good? What about 3? What do you want to do? Ooh. We probably could. We could, I don't, what do you want to substitute? Cosine squared could, there is no substitute for 1 minus sine x, okay? There's no substitute for just a sine. But a cosine squared is a Pythagorean identity. It says cosine squared can be traded for what? Now, don't divide and lose something or anything like crazy. You're just going to have to distribute. Maybe make it equal to 0. What happens? I move everything to the right. Because you know me and my, it has to be a positive A. And now it's going to factor and you guys can finish. Anyone have any ideas on number 4? Okay. We can trade that for 2 sine x cosine x. Remember, that's the big one I said you should memorize for calculus. And then we'll be able to just what? Take out a cosine and finish that one. Okay? Not finishing these, I'm just giving you some hints on starting them. What about 5?
Don't you substitute cosine squared x minus sine squared x for -1?
No. Because cosine squared plus sine squared equals 1. If we changed all the signs, we'd have a negative cosine and a negative sine. I don't know, I got thetas and x's all over the place, sorry. So the fact that we have a positive cosine but a negative sine won't let us trade it, yeah. Besides which, -1 doesn't equal square root of 3 over 2, so we'd have a mess. But yes, this is a trade. There are several trades you could make for parts of this. But the one that'll give us exact answers is if we trade that for cosine of 2x. And then this is like a U substitution problem. I don't know if anybody remembers those. If I ignore this 2,